All right, so a couple of things before we get going here. Um, on the module for reading, there was a question, I believe it was 4.5, where I had kind of some issues with the rounding. Talking with top hat people, I think we know why it's happening. So it only impacted like probably definitely less than like 5% of you. So I'm going to go in and update that later today. The vast majority of you won't notice anything. For some of you, you might see where you've received credit for 4.5 where you otherwise weren't. And that was just because there was like to the second decimal rounding issue on it that was kind of set into the question. So most of you won't see kind of any change to your grade for that. Very small percentage of you will. So if you contact me about that, I think I responded. Or if you had questions about it, I'll kind of get that issue resolved. Okay. The second thing I wanted to mention before we get going here is I put up kind of that first. Sorry, actually, there's some before I mentioned it. Got a couple emails, and I know I was explicit about this, and we've covered it a couple times. But I'm feeling benevolent at times. The very first week when I talked about these Canvas discussions, and then when I mentioned them every time in class, what were the four things we needed? An initial post. I then need to do what? Tie in the data, and then to response to other students. The actual assignment didn't remind you that you needed to respond to other students, right? Just because of my overlooking of that, once again, I know I said it week one. I know I said it multiple times in class. Because it wasn't explicitly stated in the assignment, opened up the assignment to the due date now is the end of the day today. And if you didn't respond to other students' posts, you can still do that by the end of the day today. So the new due date is 11:59. So didn't do it. Even if you knew you were, you got a little bit lucky, right? But moving forward, every single assignment has those same four components we're talking about these Canvas discussions. Okay. So the other thing I want to mention is a week from Thursday, we have the first in-class midterm exam. I'll talk more about the specifics of that exam. I mentioned some of this already kind of during week one. So 25 multiple choice question exams. I'll talk more about the procedure that we use in class Thursday and next Tuesday. But I want to get up that practice exam due early. I believe I posted it Monday morning or late Thursday last week. So I posted an announcement. I didn't want to overwhelm you with it. If you want to start preparing for that exam, like I've got this out early. After this week, next week on Tuesday, I'll probably be reviewing a lot of these. I'll ask you guys for questions. I'm not just going to pick and choose, but I'll have this practice exam. We'll start working through problem in class next Tuesday, prepare us for the exam that's on Thursday. So we've got module 4 this week. Next week, the exam's Thursday. During Tuesday's class, we'll basically be doing review. Okay? So it would be probably helpful to look through this before Tuesday so you then know what types of questions you want to ask while in classes. You're going to be the opportunity to make sure you ask the questions that you have. Later this afternoon, possibly tomorrow morning, I want to kind of go through them again just to make sure I'm giving you the most helpful questions. I've got a second set of questions or a second practice exam I'll also post. More material to be helpful, right? So we'll have multiple practice exams to kind of work through, preparing for this upcoming exam. Okay? Any other questions for me before we jump into material here? Should kind of cover all the things I wanted to mention before we got going. No questions? All right, so we will work with these slides. I'll use this Excel file at the very kind of end of class here, but we'll dive into module 4, which is talking all about price elasticity, so income elasticity, basically elasticity. Today, we're really only going to focus on the price elasticity of demand. Next class, we'll talk about other types of elasticities. So the price elasticity of demand, this is where the class builds on itself. We need to know things about the demand curve. When prices go down, in general, we said people or the quantity demanded is going to go up. Right? So we're all consumers, so this class will be a little bit easier to get in that mindset. So this relationship between price and quantity demanded was always inverse, or not really inverse, right? If the price goes up, people buy less. We knew that the slope of the demand curve was always negative, right? So if I increase the price, people buy less. If I lower the price, people buy more. Okay? Now, we could have the same change in price for two different goods, and it might lead to a very vast difference in the quantity demand. So, for example, if I change the price of a, nobody wants to look at me during this recording. So if I change the price of a candy bar by $1, that might change the amount people want to buy by quite a bit. What happens if I change the price of a new car by $1? You think that's going to change anyone's decision who is going to be buying that car or not buying that car? Probably not. So we don't just care about the change, right? What am I kind of getting at there? It's not just the change in price, it's the percentage change in price. So the price elasticity of demand starts to factor in that it's not just the change in price that matters, it's the percentage change. And then as a result, we don't care if we go from 1 to 2 units. That's a lot larger of a change than if I go from 100 to 101. So we're going to worry not about the changes. We're going to go one step further, which is we're going to be concerned with percentage change. So the measure we have for this is price elasticity of demand. It's how responsive, the word elastic means how responsive is something. So how responsive is the change in the quantity demanded to a change in the price. The way we'll measure this is through percentage change. Now, what should the value of our price elasticity of demand? It's always going to be what? We know the relationship between price and quantity demanded is slope there will be negative. So anytime I calculate this price elasticity of demand, if I increase the price, quantity demand is going to go down. If I decrease the price, quantity demand is going to go. I know this will always be a negative value, right? So what we're going to end up doing is we're going to take the absolute value. This gets easier. Instead of talking about like -5 is less than -2, but it actually measures a higher level of responsiveness. We're just going to drop the negatives when we calculate the price elasticity of demand. Okay? And that's what we'll be doing for this class. When we convert things into percentage changes, what's really nice about this measure, if I'm looking at slope, the number of units per se, I don't know, purchasing a pair of shoes is going to be very different than the number of units when I buy a box of Sharpie markers. So when we look at these percentage changes, it kind of gives us this nice unitless measure. I can compare the price elasticity of demand for any two products. Okay? So it has some advantages over just kind of thinking about our slope of our demand curve. Okay? I'll set this up, easy example. I shouldn't say easy, but I think it's an easier to follow example. If I tell you what the percentage changes in prices are, it should be relatively easy to calculate our price elasticity of demand. Okay? All we're going to do is take that percentage change in the quantity demanded and divide it by the percentage change in price. So if I know that Netflix increases the price by 50, I plug that into my percentage change in price, 50%. If they then see a 25% reduction in the number of people that signed up, that's my percentage change in quantity demanded here. I'm just taking that kind of ratio. Now, the next thing we're going to do, because it's negative, I said we're always just going to look at the absolute value. Now, we'll talk about, okay, I get this elasticity, this price elasticity of demand of -0.5, or in absolute terms, just 0.5. What does that tell me? So we'll go through this in a second, but for the kind of sake of just calculating, we'll talk first, just focus on how do I calculate this measure, and then we'll look at what does this measure actually tell me. So if I want to calculate percentage changes, right, this is where we have a problem. So if I think about the price, if I change the price from $1 to $2, what percent increase was that? If I go from 1 to 2, that is actually a 100% increase in price. But if I go between those same two prices, going from 2 to 1, I actually only lowered the price by 50%. Moving between the same two prices, the same 2 points of my demand curve, actually resulted in different percentage changes. So what we're going to do is use something called the midpoint method. Okay? So when I'm calculating these percentage changes and these in price and quantity, I'm actually going to use that midpoint method. So just a different set of values to kind of get this idea. if I go between the same two prices of 80 and 100, that's a 20% reduction. Whereas if I increase the price from 80 to 100, that's a 25% increase, right? I use more extreme examples initially, 2 and 1, to really get at this point. Right? So what are we going to do? We're going to calculate percentage changes using this midpoint method. There's other ways to calculate percentage changes, a little more complicated, outside kind of what I expect for this class, but we are only going to use this midpoint method. So the way that we'll calculate a percentage change between any 2 points, so it doesn't matter if I started at the price of 2 and went to 1, or I started at the price of 1 and went to 2. Between those same 2 points, the way we will calculate that percentage change is look at the change and divide it by the average of those two numbers. So the percentage change in my quantity demanded will be the change in my quantity demanded divided by the average of those two numbers. How do I find the average of two numbers? I add them up and divide by 2. This should be not, hopefully we can find the average of two numbers. Okay? Now, I could kind of rewrite this. It would look a little more complicated, but if I'm just saying, well, what is the change in quantity? Change, right? Quantity 2 minus quantity 1. What's the average? Adding those numbers up, dividing by 2. I would do the same thing to calculate the percentage change in price. Now, I'll work through an example where I can show you maybe breaking this down into steps might help this be a little bit easier when we're making these calculations, right? So, and then what did I forget to mention? At the end, we always just take the absolute value. So these kind of bars, that just means take the absolute value. Basically, ignore the negative sign, right? So let's kind of use an example, and I'll show you how I would work through this instead of thinking about, okay, what do I plug in where? And my parentheses start to get confusing. I think it's easier if I kind of break this down. And instead of using this more complicated version of the formula, let's think about what we're doing. So I start out with this price of 6, and I'm then moving to a price of 4. Okay? As a result, the quantity that people are buying of this good is going from 15 to 25. Okay? So when we're talking about this elasticity of demand, and this will help us next class when we start to talk about other elasticities, but it's the percentage changes that we care about. So it's the percentage change in the quantity demanded divided by the percentage change in price. So the thing that is in our denominator is going to be the thing that is initially changing, right? Firms increase or decrease, or when you go to the store, the price you see is going to be something different. As a result, the thing that is responding to that price change is the quantity that people want to buy. So this word of elasticity is responsiveness. So what always goes in our numerator is the thing that is responding, and what's in our denominator is the, sorry, did I say this? The thing in our numerator is what is responding, the thing in our denominator is what is initially changing. Now, here's where it gets a little confusing, and we'll talk more about this relationship here in a second. But when we were looking at demand curves, how did I find the slope of a line? I looked at the change in what's on my y-axis divided by a change in what's on my x-axis. So when we calculated slope, we had the change in price and the change in quantity demanded. What do you notice is true about our elasticity measure? It flips those. It's the inverse. So the relationship between slope and elasticity is actually going to be an inverse relationship. When slope is high, elasticity will be low, vice versa. So we know it seems a little counterintuitive for right now, but this is how we're going to calculate our price elasticity of demand. I hope by the end of class it'll make a little more sense as to why these two things aren't quite the same. Now, just going through the mathematics of this, and then I'll kind of mention a little bit more about what this is telling us. I would break this down into the following steps. I'm going to first find this numerator, okay? How do we say, using that midpoint method, I calculate percentage changes? It's the change in my quantity, or change in my quantity demanded, divided by the average of those two quantities. So what is my quantity changing by? It's going up by 10. So instead of writing out like the notation of what a change is, I think we all know what the change between two numbers is, right? It's the second number minus the first. So I think it just makes it a little more, okay, I want the change. I don't have to write that out every single time. I can look at those two values and see the change is 10. Now, what would the average of these two values be? I would simply add them up and divide by 2. Right? So if I add these up, divide by 2, I would get what? 40 over 2 is 20. Now, here's where it gets a little bit weird. If I do the intermediate calculation, when I calculate these percentage changes using the actual numbers, they won't represent it in percentage form. It's going to be in decimal form. So for example, if I had a probability of 0.2, what is that as a percentage? You would take that and multiply by 100. So when we do the intermediate calculation, we'll have the percentage. It's just in decimal format. So here, what was the percentage change in quantity using the midpoint method? It would actually be 50%. But we're using kind of this intermediate calculation, we would see that in decimal form or 0.5. Now I've got my numerator. How would I find the percentage change in price? Well, that's the change in the price divided by the average using that midpoint method. What was the change in my price? It went down by 2%. What is the average of these two prices? 5. So I get negative 0.4 as the percentage change in price. Well, if I use these intermediate calculations, I now simply have two values. I can plug in, I get this elasticity of negative 1.25. Now, what did I forget to do? Yeah, it's always going to be negative. We just care about the size, not the sign, because we always know the price elasticity of demand is going to be negative. So we've got a price elasticity of demand of 1.25 here. Okay, so this is where we've focused on how do we actually calculate these values, either given a percentage, and that's pretty easy, just plug in what those percent changes would be, or if I have the two prices and the two quantities, the points that I'm moving between on this demand curve, how do I use that midpoint method to kind of make that calculation? Solve for that calculation. Do the calculation to solve for that price elasticity. Any questions on anything here? Because the next thing we're going to dive into is probably, we care about being able to calculate statistics, but what's more useful in the real world is we need to know how to interpret them. So I shouldn't say it's more useful. Computers can do a lot of calculations for us now, so the human component that actually is going to get you paid is how to take those statistics and apply them, right, and interpret them. So let's say, kind of setting this up, I've got this elasticity of demand that's 1.25. I might go a little bit out of order of the slides here, but we'll cover the same material. So if I've got an elasticity of demand, and let's say it's greater than 1, right? That's what we just found, a value greater than 1. What is that really telling me? Well, the elasticity of demand we know is the percentage change in the quantity demanded divided by a percentage change in price. If this is greater than 1, if I rearrange this equation a little bit, multiply both sides by my percentage change in price, what do I end up with? Well, what's the only way this fraction is greater than 1? If the numerator is greater than the denominator, or if I rearrange this equation, what do I see is that when the elasticity of demand is greater than 1, it must be that that percentage change by consumers and how much they were buying was larger than the percentage change we saw in the price, right? So this would be something like they only changed the price by 1% and people bought 50% more of this good. Oh, sorry, they lowered the price by 1% and people bought 50% more. So anytime this is the case, we say people are being very responsive or very elastic, right? So anytime people are responding by a larger percent that they're buying than what the initial change or percentage change in the price was, they're being very elastic to that change in price. So I'll maybe help kind of link some things you maybe already talked about, or just a different way of thinking about this. In physics, if I apply a force, a rubber band is elastic, right? Why do we say that? Because when I apply a force, it is very responsive, right? It pulls apart. Same thing here. When we see a force applied, a percentage change in price, if consumers are very responsive, right, very elastic, they're going to buy a lot more or a lot less depending on which direction that price change, right? The price is the force. If I have something that's very inelastic, I'm applying a force, is it changing? Is it? No, right? Solids in physics are inelastic. I can apply a force to them, they don't change. Same idea with demand. If I'm applying that force and I'm changing the price by a lot, if people are very inelastic, what's going to be true? They're not going to be responding to that change. If I ever end up with a price elasticity of demand less than 1, that means that this percentage change in quantity demanded relative to my percentage change in price, what's the only way this fraction is less than 1? If my denominator is larger than my numerator, or that percentage change in price is larger than my percentage change in the quantity demanded. If it helps, put numbers to it. A 50% change in price, if it only results in a 10% response by consumers and how much they buy, they're not being very responsive, right? The price is going up by a lot, and they're not buying that much less. All right? So there we would say anytime we have an elasticity measure less than 1, consumers are being very inelastic. They're not responding to that force. Here our force is just a change in price. Any questions over anything there before we throw in another wrinkle? Okay. I forget to do this every single class in between the two sections. Hit this button so that it doesn't time out on me. Sorry, I'm frustrated with myself. But we can kind of continue this discussion. We have elastic and inelastic. Let's think about the two extremes now. Okay. So let's say I had the most elastic good. Okay. So if we think about what that elasticity of demand equation is, we've got this here. What would be the most elastic thing we can think of? Right? Well, there would be people being very responsive. So if I had a percentage change in the price that was very, very small, right? If people are very responsive, what is the percentage change in quantity demanded? It's going to be very, very large. Or I could think about an insanely large value. What is this going to get really close to? So let's think about it here. Maybe some of you more kind of have a higher math background. If I divided any number that's really large by what's the smallest change I could see? 0. What does this in the limit become? Infinity. Right? Anything divided by 0 is infinite. So this would mean that anytime consumers are perfectly, perfectly elastic, right? Even if there's no change in price and all of a sudden people buy more, well, they're responding to an infinitesimally small change in the price. Right? So perfectly elastic is going to be when we have an elasticity measure that's infinite. Right? So what is an example of something that's perfectly elastic? We probably don't have a lot of, nothing in the real world is probably going to be perfectly elastic. There'll be things that get close. So the example I think of is something like, if I go to a restaurant, I got to think about something where an infinitesimally small change in price would result in me decreasing the amount I buy by a lot. So if I go to a restaurant and napkins are free, how many do I use? Probably more than I need. Just grab a handful, I only use a couple of them, I throw them all away, right? What if that restaurant starts charging me even a penny to use those napkins? First of all, I don't carry around change. I don't want to run my debit. How many napkins do I maybe use? I'm going all the way down to 0, right? So a very, very small change in price led to me a large percent change. I might have used 10 before. Going from 10 to 0 is a very large percentage change. There's nothing that's probably truly perfectly elastic, but there are things that get closer to that extreme, right? Plastic bags is probably another good example.
There are examples of like advertising where no price change and the demand goes up to some strength or something. And how do you know those?
So that's not talking about the price elasticity of demand, right? It didn't. There was no change. So that's would be like the advertising elasticity of demand, right? It's how responsive consumers were to other things. We're only talking about the responsiveness of changes to what? Changes in the price. Other things can change that impact demand. We're not focusing on that. We're only focusing on the response by the quantity demanded to a change in the price of that good. Yep. So there's probably not a perfectly elastic good out there, but there's things that get close. Example like charging for plastic bags, and my example of napkins. But we want to think about the extremes to kind of think about what's in the middle, makes it a little bit easier. So I'll give you one where there is an example, right? So the next extreme, if I have perfectly elastic demand, what could I also have? Perfectly inelastic demand. What would that look like? Well, if people aren't being very responsive, I could see a huge percentage change in the price. If they're not responsive at all, what would the percentage change in their quantity demanded be? If you don't respond, 0. So my elasticity, if it's ever 0, there I have people aren't responding at all, or they're being perfectly inelastic. What are some examples of this? So I've got one in the slides, but I'll make it go through a better example. So perfectly inelastic goods, the way I always think about these is things that people are addicted to, right? I see a ton of like Zins and stuff that people have like spit out on the floor, right? So when you think about drugs, things that people are very addicted to, like heroin, right? If I'm addicted to heroin, I might kill someone to get the same amount of heroin. I'll pay a very large price. I mean, this happens, right? I'm not stupid example, but it happens, right? So you can change the price of heroin by a lot, and how much do people keep using if they're addicted to heroin? Same amount, right? So they're unresponsive to price changes. They're perfectly inelastic if I'm addicted to a drug, right? So we do see goods that people are literally killing to get that they are perfectly inelastic. They'll pay the highest price. Right? Adrenaline junkies, you could argue, are perfectly inelastic. There's that guy that just climbed some building like without any like rope. He must be so addicted to the adrenaline of free climbing. He was okay if he paid the ultimate price and fell and died. It's perfectly inelastic, right? So we do have, I think, examples that get really close to perfectly inelastic. Let's see a hand over here. Yeah,
like taxes.
We'll talk more about what companies and governments could do. We'll talk later on. We'll tie this into. So this is where the class continually builds. So in module, I think it's 6, we'll relate taxes and subsidies to elasticities. Yeah, if I know that people are going to buy the same amount regardless, if I increase the price, what can I do? Tax that good and make a bunch of money. All right. So those are my crazy examples, right? And I've got another one in the slides that we'll talk to just to kind of hammer this point home. But I then like to think about this as a number line to kind of help keep track of this. Okay. So we said if someone is perfectly elastic, they're responding by a lot to a very, very small percent change in the price. So here we kind of had this set up as really high values for our price elasticity of demand are getting closer and closer to perfectly elastic. Is anything truly perfectly elastic? Probably not, right? And then on the flip side, when I had a price elasticity of demand of 0, we were thinking about things where people aren't responding at all to price changes. I don't know, maybe even heroin, there's a slight, right, change in how much people buy. They might buy the same amount and try to make it go a little bit longer or something like that, right? But a perfectly inelastic good would have an elasticity measure of 0. We then talked about these different ranges where if my elasticity of demand is less than 1, that told me that the percentage change in the quantity was less than the percentage change in price, or people were being fairly inelastic. If I then have the elasticity ever be greater than 1, the percentage change in how much people were buying was larger than whatever the initial change in price was, percentage change in price. We said they were being elastic. Now, I kind of glossed over this one point, and we'll use it next class when we start to talk about a different concept. So I want to mention it here. what if my elasticity of demand is exactly equal to 1? So we call this unit elastic, but what would that mean about my percentage change in price, right? If my elasticity of demand is equal to 1, it would have to be that my percentage change in quantity, is what relative to my percentage change in price? The exact same thing. So it could be that there was a 50% change in the price and I bought 50% less. It could be a 5% change in the price. So I bought, changed the amount I bought by 5%. Unit elastic is when these changes, these percentage changes are the exact same value. Doesn't have a lot of meaning for us right now, other than we can kind of think about it's just something that kind of a point that separates goods into being either price elastic or price inelastic. Okay. Any questions on anything here before we keep moving? Okay. All right. So I think I went through a lot of this already. Oh, if I can get the touch screen to respond. There we go. So we talked through making these calculations. Once again, if you want to plug, think about like the most extreme version of this price elasticity of demand using the midpoint method formula. You can plug everything in here, but on a calculator, it's really easy to make a parentheses mistake. I would suggest if I asked you to do this on the exam, breaking it down to steps like I kind of showed you. It just makes it less likely to make an error with the parentheses, right? So we had that value of 1.25. We talked about these different ranges and kind of the relationship between the percentage change in price and the percentage change in the quantity demanded. Why we called values greater than 1 elastic, less than 1 inelastic. People were being very unresponsive to price changes when it was inelastic, very responsive to price changes when it was elastic. Now, when we have these 5 different classifications, we also want to make this connection between price elasticity and slope. Okay? So I'll use those same ranges we talked about to talk about this relationship. And then I think I have a different way of depicting it to you to maybe help sell this idea home. So we've already talked about some of this. So if I have perfectly inelastic demand, people are not responding at all. So the percentage change in the quantity demanded was what? They don't respond to a price change. The percentage change in quantity demanded is 0. 0 divided by any number is going to give me an elasticity of 0. Now, if I'm calculating the slope of this demand curve that's completely vertical, well, why was the percent? I had percentage change in price, but quantity stayed the same. So the percentage change in quantity was 0. If I calculate slope, it's going to be the change in my y-axis divided by the change in my x-axis. So there I would have a change in the price divided by the change in the quantity of 0. We said earlier, any number divided by 0 would be, in the limit, infinite. So my price and my slope end up being exactly the opposite. When my price elasticity of demand is 0, my slope of that demand curve would have to be infinite, or to have a completely vertical demand curve. If instead, we'll kind of come back to this, I have perfectly elastic demand. People are very responsive. Well, we said there's probably no good when this is truly the case. Most of them might think about, I've got no change in the price, but all of a sudden people buy more, right? Or people buy less. So there, what might elasticity measure be? Well, any number divided by 0, so any response in quantity demanded to no change in price, we would say the elasticity there is infinite. Is anything truly perfectly elastic? Probably not. But you can help, it helps you to think about it. Something where if the price went up by the smallest percent, people buy way more or way less. That would be a close to perfectly elastic good. So there, we're going to have a horizontal or very close to a horizontal demand curve. So it was perfectly elastic. All right, what would the slope of my demand curve actually be? Well, the change in price over the change in quantity, what's the change in price here? 0, so my slope would be 0. Right? Slope of the horizontal demand curve, change in y over change in x. The change in y here was 0. So this is where slope and elasticity are the exact opposite of each other. All right? When my price elasticity of demand is infinite, when I have perfectly elastic consumers, the slope of that demand curve is actually 0. So there's this inverse relationship between slope and price elasticity of demand. Any questions on that before we keep moving? Okay, so all right. So the kind of range in the middle, if I had a good that was not perfectly inelastic, but somewhat inelastic, just to kind of give you a visual depiction, and this isn't 100% accurate, but I think it helps sell this idea. Let's say I see this percentage change in price that I think it shows 10%. If that percent change in price leads to a smaller percentage change in quantity demanded, well, then I would have a numerator that is smaller than my denominator. So my elasticity measure is less than 1, or this would be a good that's relatively inelastic. What do you notice is kind of true about the slope of that demand curve? It's fairly steep. The most extreme, we said when it was perfectly inelastic, was the steepest possible slope we could have, right? So when it's just inelastic, and we have this elasticity that's less than 1, the slope is going to be a relatively large value or large negative value. On the flip side, if I had, so this is an example, this guy, does anyone know who this is? Yeah, right. Martin Scarelli, or I forget how to say his last name, but he basically bought the rights to HIV drugs and then like increased the price by like some ridiculous amount, like drugs from like a couple hundred to like in the thousands, right? Why did he do this? To the point earlier, he knew that if I have HIV, I need these drugs, right? So what am I going to do? I'm going to pay whatever price required to stay alive. Or my demand was like very, very, very inelastic. You change the price by a lot, I'm going to keep buying the same amount to stay alive. So that's kind of another example of an inelastic good. If on the flip side, we think about not a perfectly elastic good, but something that is fairly elastic, I could see that same percent change in price, right, that we had for an inelastic good. But if consumers are very elastic, the amount they buy won't change by a small percent. The amount they buy is going to change by a percent that's even larger than the initial percentage change in the price. Right? So here, if my numerator, right, that percent change in the quantity is larger than the initial percentage change in the price, I'm going to have a fraction that is greater than 1. But notice when I have elastic demand, what starts happening to the slope of the demand curve, which is becoming flat. Okay? This elasticity measure and slope are inversely related. And we kind of think about the two extremes to make that point, but maybe it kind of helps here to think about kind of those ranges in the middle. And then if I ever had a percentage change that was a percentage change in the price that was exactly matched by the percentage change in how much people bought or the quantity demanded, there I would have a numerator that's the same value as my denominator. That would be my unit elastic demand. Once again, we're just kind of setting this up because we'll use it more next class when we start to talk about total revenues that companies earn. So these were, I kind of put them on a number line. These are our 5 ranges, right? We can now start to think about some different things with this. So one thing I wanted to kind of go over is a different way of thinking about, just making sure we have enough time to do what I'm thinking about time, sorry. There's another way of thinking about this relationship between slope and demand. But I think this will maybe help a little bit. Let's say I've got my quantity demanded here, and I've got my price. Okay. If I've got a pretty flat demand curve, the slope is going to be pretty close to what? The flattest curve, horizontal, would have a slope of 0. So this is going to be close to 0 slope. So if I think about this demand curve, and this is where, when I took an introductory to economics class, I remember I had an instructor and he used like rulers on the chalkboard. This is why. I'm trying to draw this as best I can, proportionally in straight lines. But let's think about here. If I went, well, I'll make this easier. Let's say this is price 1. So I'm lowering the price, right? And as a result, here's the kind of change in the quantity people are buying. This percentage change in price, right, is going to be relatively, so if I think about my elasticity of demand, Here I've got percentage change in quantity demanded, and I've got my percentage change in price. This percentage change in price is going to be relatively small. I don't know, I could think of a value maybe like 2%. What did that small percent change in price do if I had a flat demand curve? The percentage change in quantity demanded was going to be relatively large. Once again, I could think of like a large percent change. Okay, so here I've got my elasticity of demand is 25. That's definitely greater than 1, right? So when I have a flat demand curve, I'm going to end up with a pretty elastic, right, demand. Okay? So greater than 1, I've got kind of very elastic demand when I've got a flatter demand curve. So the flatter the demand curve, the higher the price elasticity of demand. Thinking about the same graph, let's say I've got not perfectly inelastic, but a pretty inelastic demand curve. Or I've got a pretty steep, right? What is the slope going to be here? It's going to be getting steeper and steeper. So this is going to be getting, a very large value, getting closer and closer to infinite. It's not infinite here, but you could think about maybe it's something like, I don't know, the slope is negative 10,000. So if I now think about the elasticity of demand of this second demand curve, the reason why I put them on the same graph to kind of get at this idea is notice I've got the same, percentage change in price, right, as I did before. But for this new demand curve, so I've got a pretty small percentage change in price. Now here, it looks like it might be about the same percentage change in the quantity demanded. So let's say I had an even more extreme demand curve, that the percentage change in my quantity demanded is even smaller. So maybe this was initially a very small percentage change in price, but on my second demand curve, I get an even smaller percentage change in the quantity demanded. Well, here, this would be what? A price elasticity of demand of 0.5 or less than 1. Or notice when I have steeper demand curves, my demand tends to be more inelastic, right? There's this inverse relationship between slope and elasticity. Right? The steeper the demand curve, right, the more inelastic or closer to 0 my price elasticity of demand will be. The flatter the demand curve, the more elastic or the higher that price elasticity of demand will be. And I kind of like putting these on the same because it's the same percent change in price that's resulting in a very different response by consumers. So this would be like the demand for 2 different goods. Any questions on this idea before we keep moving? Okay, so what I'm going to do here is go to this quiz, and this is where I said this last class, but sometimes people don't listen to me. All right, I'm setting this due date in time. You can see what it is. It is 10:28. Okay, so I will prompt you about 2 minutes before this time is to make sure you're getting this quiz submitted. If you don't submit it by this due time of 10:28, I'm going to assume that you weren't in class when we worked through this, right? And you will receive a score of 0. So I will always prompt you in class to make sure you get it submitted a couple minutes before we review them. So there's this buffer to make sure you get it submitted. Okay? So I'm going to then open this up. So it's published. It should now be on the main homepage. Right? This is always the same procedure we'll keep using, but some people, they miss classes. They're, not just mention this since they're so early on. When you click on this, it should ask you for a code. So it should be 23.81. 23.81. Verify that it's getting you into the quiz. Yes, yes. 23.81. So I'm going to give you the next what? 9 minutes or so. Work on this, or I should say 8 minutes or so. Talk to people around you. There's 3 questions. So I'm going to let you know in advance. We haven't talked through all 4 of the questions. So the first 3 you are responsible for. The very last question, I'm going to give you the answer now, so everyone will hopefully get it correct, which is that it is a greater proportion of someone's income. I'm going to go a little bit out of order. I'll probably re-upload the slides because we'll talk more about determinants of demand next class. So everyone should get question 4 right. It's a greater proportion of someone's income is the answer. You'll have to work on the first 3, talk to people around you, kind of come back together in about 7 minutes or so and kind of talk through these. Okay? Huh? Not loading. Is it loading for some people? So it might just be bad Wi-Fi. Try to hit refresh a couple times to see what pops up. I'll move the time in case we need a little bit more time here. You getting it pull open now? Is it working now? Yeah, so it's not pulling open. Just wait a minute, refresh, hit refresh a few times. God. Yeah. 23.81. Excuse me.
Or is it?
Some of these are probably, these in-class questions are probably easier. I would say that practice exam I'm giving you for a reason. So that second, the first one and the second one I post will probably look more similar to the types of questions you'll see. I'll go through a little bit more, maybe next class for sure Tuesday. The order in which I'd study things, which is usually the practice exams, old quizzes, old practice problem sets, and then in-class quizzes might be the next. There should be. There should be one every week. Now you've got me worried, but I'll look and make sure. Every week at the beginning of the week, I post the practice problems. Okay?
Oh,
So they're just on the homepage.
they are there.
Every module should have like quiz 3 materials. They'll have the practice problems at the beginning of the week, and then that's where I post the quiz as well. So if you scroll through the homepage for every module under where it says like module 1 quiz materials, I forget exactly what I called it. It'll have practice problems, practice problem answers, and then the quiz. Now you can't see this week's quiz. I post the quiz there once it's open, but yeah. So I'll mention it in the class what I'm excited to review. These are probably a little bit easy, right? Because it's the first time you've seen the material. You know, I'm not trying to make them as hard. I'll talk to you with before you class. Not trying to not answer the question. All right, so I moved the time a little bit later since there was some loading issues, so I think it's set to be 10:31. So making sure you're getting that quiz submitted, I'm giving you plenty of kind of buffer time. Now here's where I'll usually review these. Usually giving you a couple minutes. Like you're not going to review them, don't hold off to submit that quiz. If it's submitted late, it's a 0. You've got plenty of time to kind of get that submitted before 10:31. Now, the other thing I kind of mentioned was I was giving everybody the answer to problem 4, so you can bend it out here. I said the answer to 4 was what? A greater proportion of someone's in. Okay? So everybody should get question 4 correct. The other 3, you know, I want you guys to talk to the people around you. You're at Kelly in the school business. Make as many connections. Don't be shy. And talk to people. They might know something that you don't. Let's try to work together a little bit. But this is generally kind of how we'll do these in-class quizzes. So the first 3 questions, right? So once again, make sure you're getting these submitted here before I have it set to be 10:31. No excuse to not getting this submitted in time. Okay. So if I'm thinking about, this is one where I'll work through a little bit more time. I'm going to go a little bit out of order, right? So we'll do question 2 first. Right? So I initially had this price for a gym membership of 30. It was going, of 20. It was going up to 30. As a result, the number of memberships I sold was going from 120 to 100. We said, how can I calculate this price elasticity of demand? So remember, what's in my numerator is always what is responding, and this will help us next class, to a percentage change in the price, or what was the kind of initial thing that was changing. So how did we say we calculate percentage changes in anything? So next class, we'll even start talking about things like the income elasticity of demand. Okay? So that percentage change in the quantity demanded is always going to be a change in that thing divided by the average, right? So here, what was my change in the quantity? It was going down by 20. The average, if I add these up, divide by 2, I think I get what? 110. Okay. So I think this is approximately like negative 0.182 if I round it to the third decimal. Okay. I then said the next thing I would, so I've got my numerator. What is the percentage change in price using that midpoint method? Well, once again, it's the change in that thing divided by the average. What was the change in my price? Went up by 10. What's the average? Add those numbers up, divide by 2, I get 0.4. Okay. So if I'm calculating my elasticity of demand here, I now have my numerator, negative 0.182. I've got my denominator of 0.4. If I do this, I think I get, I forgot what it's going to be approximately, if I round to the third decimal, I should get about 0.45, right? Now, here's where if you use, like, let's say you had a scientific calculator and you use the actual values to do the rounding, I'm never going to give you like 0.45 and 0.46, right? It'll never be like in these multiple choice questions similar to the exam. I'm never going to give you two options where the rounding is going to result in identifying the answer incorrectly, right? It'll be close enough. If you like round it a little bit more egregiously and hit 0.18, right, you're going to get like 0.46, I think. So it'll be kind of obvious like what the closest answer would be you would go with. Now, I also kind of gave every answer here on the question 2 was positive because what do I do when I'm done? I look at the absolute value. Okay. Also, when I was thinking about these, if my numerator is smaller than my denominator, what answers could I rule out right away? I knew the elasticity demand must be less than 1, so I can rule out anything that's above 1. Okay. Or I would say demand was what here? If the elasticity is less than 1, if a follow-up question was, is demand elastic, inelastic, or unit elastic? Less than 1 means demand would be inelastic. Which I believe, if I was looking at question 1 was a little bit easier because instead of asking you to calculate those percentage changes, I simply gave them to you. So I know that if I had a change in textbooks of 24%, and as a result, people bought 15% less. Well, if I'm responding by a percentage that's less than the initial change in price, am I being responsive or non-responsive? Well, my response was smaller than the initial change, so I'm being pretty unresponsive. Remember, what does the word elasticity mean? Responsiveness. So if I'm unresponsive, I'm being very inelastic, right? Or what's the more technical way of identifying that? I get an elasticity that's less than 1 here. The numerator is smaller than the denominator. We had a similar example where just like in 2, I've got inelastic demand. And I should have technically put my absolute value sign there, right? We always just kind of drop a negative. Any questions over these two before we keep moving? Okay. So on question 3, I think I'm asked about perfectly elastic demand. So if I have perfectly elastic demand, that means that people are being very responsive to even small changes in price. So if I have a very small percentage change in price and people are being perfectly responsive, this value is getting closer and closer to what? So if I divide by 0.000001, that's going to be a really large value, or it's getting closer and closer to being infinite. Right? So that's going to be the thing that is true. We're looking for which of the following is true. Okay, well, it said the price elasticity of demand is 0. That's not the case. Okay. Here, if I'm thinking about what would a perfectly elastic demand curve look like, that means that even when I'm seeing infinitesimally small changes in price, I'm getting really large changes in my quantity demanded. So there I would have a completely horizontal demand curve. So it's not vertical, it's horizontal. what would the slope of this horizontal demand curve be? Well, this is, once again, if I can't remember that's a horizontal demand curve, what do we say is true about elasticity and slope? That's the relationship is completely inverse. So if my elasticity demand is infinite, my slope for a perfectly elastic demand curve would be the smallest possible values. Okay? So that's going to be the one that's true. Right? We have a slope that's equal to 0 here. Okay? Representing that people, if I have an infinite price elasticity demand, they're being very responsive. Those two things are inversely related. Okay? Any questions on any of those before we keep moving here? So I'm going to talk about one more thing to kind of set us up for next class. I then have a data example that we'll kind of work through, and I have some statements to make about the exam before we leave today. Okay? So one thing we'll start talking about next class, but we've really set ourselves up to already be able to understand it. So up to this point, I've kind of been talking about like thinking about elasticities of different goods, right? Comparing and contrasting different goods elasticities. What ends up being the case is we have different elasticity measures on the same demand curve. So I'm going to be a little bit lazy and kind of the numbers I use and not think about the specific values, but more of the concepts to get at this, okay? So let's say I had a demand curve, and when the price was going from 100 to 99, the quantity demanded was going from 1 to 2. So if I think about my elasticity of demand, that's the percentage change in quantity demanded over a percentage change in price. What is going from 1 to 2? That's a very, well, what would the percent increase be there if I didn't use the midpoint method? 100% increase. It's a large percentage. I could actually calculate this percentage, and I think if I use the midpoint method, it's going to be what? 1 over 1.5, so 3 over, so what, 150% or something like this. So whatever, right? All we care about is it's a very large percent change in the quantity demand. That same change of 1 in price, if I start at 100, it's going to be a relatively small percentage change. So my elasticity measure is going to be greater than 1. Just to think about some hypothetical values, let's even say this was 50%, this was 2%. I end up with 25, well above 1, right? So up here, when prices are high, changes in price are going to be relatively small percentage changes. When prices are high, quantity is going to be low, so we're going to have relatively large percent changes in quantity. Okay? Now, let's say I'm thinking about instead the same change in price. Right? I'm on the same demand curve. I've got this 1-to-1 relationship. The slope is -1. Well, when I'm down here and I'm thinking about calculating that price elasticity of demand, going from 2 to 1 is going to be a relatively large percentage change in the price. We can kind of think about like before, it's like a 50% change. Now, quantity is going from 99 to 100. That's going to be a relatively small percent change in quantity demanded. So I'm going to end up with an elasticity that's like what? Here I did 1 over 25, so 0.025, really small. It's going to be less than 1. So down here on the same demand curve, the price elasticity of demand, I'm going to have that it's inelastic. So on the same demand curve, our elasticity or our price elasticity of demand actually changes. Okay? That when we're looking at lower and lower prices, what's happening to the elasticity of demand? It's becoming more inelastic, right? So when prices go down, our demand being on the same demand curve, we're going to end up with more inelastic price elasticity of demand. Right? So here we can compare across goods by calculating the price elasticity of demand of where those current goods are at on their demand curve, but the same good at different prices will become more or less elastic. Think about it this way. If I have a new car, the price goes from, I don't know, $1 to $2, right? People are going to be, it's a very small percentage change in the price. but people are going to want to buy. Everyone's going to want to buy a new car, even though think about the price going from. Let's do it this way. Let's say the change in the price of a new car goes from 2,000 to 1,000. Relatively large percent change in the price, but people are probably going to really want to buy a lot more cars if they're new cars if they're only 1,000. So there's a huge change in the quantity demand, right? Or we start out at relatively kind of the same percentage change in price. It's going to be much lower the percent change in quantity demand. We're going to have relatively elastic demand. It could be anything, right? It doesn't have. I just used an example of linear, so we have the same values to compare here at both ends. It doesn't have to be a linear demand. This relationship of the fact that when we're lowering the price, demand is becoming more and more inelastic. Right? This is the idea of, I guess, for a new car. If I went from 2 to 1, I'm not going to see a huge change in the quantity demand because everyone's going to want to buy a car at either price. But when the price is really high, going from 40,000 to 40,001, is that going to change my quantity demand by very much? So we have this idea of the elasticity. As I move to lower and lower prices, I'm getting more and more inelastic demand. So that means there is going to be a point where my elasticity, so here it's greater than 1, here it's less than 1. There will be a point where it's exactly equal to 1, or we have unit elastic demand, right? So we're going to use this idea next class that the elasticity, price elasticity demand changes at different points on the demand curve to then think about if I'm a company or we have a market that we see a resulting price, what's going to happen to total revenues if I could set the price as a firm, right? So we'll use this concept next class to explore the idea of as I change the price as a firm, what will happen to the corresponding total revenue depending on whether demand is elastic or inelastic. So I'm setting ourselves up for next class. We'll do this very quickly, right? But this is kind of the idea of like why this is the case. Okay. So for the rest of the class, we'll look at is I had on the home page this movie example. What did I call it? Elasticity example for movies. So this isn't something that would like show up on the exam in terms of like using data sets. You guys are in the school business. I can't imagine there's many jobs you're going to get when you leave here that they're not going to expect you to work with data to some degree, right? Even if you're like one of these marketing people that just try to come up with innovative ideas, you're going to need to support your ideas that's actually going to change how much people are buying. You're going to need to use some statistics to support why you're doing what you want to do. So I went out and grabbed this information. Oops. I was showing you where that was at. It wasn't on the screen. So it's just under that kind of module 4 heading. So if I wanted to calculate elasticity, so I had some movie theater ticket data. I have the price on average in that here, and I have the number of tickets sold. Right? So notice before COVID, like it's kind of nice. Like when prices were going down, right? I actually had some weird things where like quantity was actually not going up, but that's because there's plenty of other factors that are changing year to year. But just to kind of have a small data set to show you this, if everything else stayed constant, right? What's happening to the price elasticity of demand? Okay. So what I could do, I took this year that was like right before COVID happened, right? So there's some weird things with COVID, right? The number plummets because movie theaters weren't open. But here, if I wanted to, I can calculate the percent change in the quantity by simply taking the change in the quantity between those 2 years and dividing it by the average, right? Adding those two numbers is the midpoint method. I could also do the same thing, but the percent change in the price for those 2 years. Now notice here I have very small changes in the price, but I'm converting those to percentage changes. Okay. So once I have these percentage changes in the quantity and the price, all I do is take that percentage change in quantity demanded, divide it by the percentage change in price. I got a little bit lazy here. I technically should have taken the absolute value, right? So we can then just kind of compare. So I get an elasticity of 11.9. Is demand for movie theater tickets between these 2 years is elastic or inelastic? It was very elastic. Movie theaters started to increase their prices. Fewer people are going to go. Now I could do the same thing between two earlier time periods, right? Here, once again, we'll take the absolute value just so we can kind of compare a little bit easier. So over time, what is happening to the elasticity of demand for movie theater space? It's actually going down, meaning that people are more inelastic. So we'll talk about some determinants of demand. This is actually a little bit surprising. But the way I think about this as over time, what has happened? Instead of going to a movie theater, you have a lot more available options where you can watch that movie in the comfort of your own home, right? So the only people who are still going to movies in the theater are people who really like to watch movies in the theater. So if you increase the price by a lot, what's going to happen to their percentage change in how many movies they want to see? It's going to go down, but it's not going to change by much. The only way they want to watch a movie is they love that experience. They're more inelastic, right? They're unresponsive to price changes. Now, something that I'm not sure I believe the data completely here, but let's just for the sake say it's true. To the second decimal, between 2024 and 2025, what was the percentage change in price? Nothing. But were people buying more or less tickets? More. So what are they being? Perfectly, they're responding, even though there was nothing to respond to, so they're being perfectly elastic, right? We would have an elasticity measure here of infinity. Now, even though I can't see it to the second decimal, if it's following our law of demand, if the quantity of tickets went up, what must have been true about the price here? It actually went down. If we were to be able to have this data out to the third or fourth decimal, my imagination is it was a little bit lower price on average. The data that was presented was just rounded to the second decimal. So if that was actually the case and there wasn't, we would actually have perfectly elastic demand. It's very weird.
Like, I understand that we're just talking about price, but couldn't there also be like other
There's plenty of other things that will impact our demand, right? We're assuming in this example, we're holding all those other factors down. But even if we don't, changes in income will change the amount people buy. But changes in income won't necessarily influence the relationship between the price of that good and the amount purchased of that good. So yes, we have other elasticities, income elasticity of demand, complementary substitute good price changes, elasticity of demand. But that doesn't necessarily mean when those things change, the relationship between price and the quantity, it's not impacted necessarily by those things.
The average ticket price also exists.
No, I didn't adjust anything. So that could be tagged. I'm not trying to make this like the most complicated example. We got to walk through. I'm starting out with kind of a simple, just thinking about if this represents prices and quantities. If it like maybe make it easier to help you think about it, let's say it was adjusted for inflation. There, then we would be more accurately capturing just changes in price. Yep. Okay. So before we kind of get out of here, I do want to start to outline. So I'm guessing at the end of next class, we'll have a little bit of time to kind of start doing maybe some review. Okay. So I've been asked a lot, so this is why I'm saying it now, so I don't have to repeat it a lot. The order in which I would start to study for this upcoming exam. All the materials you have, once I get that second practice exam out there, I would suggest going over first those practice exam questions. It's called a practice exam for a reason. The structure of the questions, content, the ordering, everything is written as though it was essentially an exam. So those would be the things I would make sure I review and understand first. The next thing I would move to is what else are you evaluated on? Quizzes, each module. So the second thing I would review would be the old quiz question. Now, module 4 quiz is not going to be due until next Monday, so you're going to have a little bit less time to be able to review those questions. But you've got the first 3 quizzes, you can go back and start to review those. The next thing I would then review after reviewing the quiz questions, how did I ask you to prepare for the quiz questions? I gave you every week practice problems and answers, right? After I review those, I then would probably go back to the in-class questions. The order of those things, the difficulty is probably going to be fall, right? So that's why I'm giving you this order, because you probably want to review the most complicated, the harder questions first that are going to look more like that multiple choice exam. And we'll talk more about the structure of that exam next class. There's also one more thing I wanted to mention before we get out of here. So for those CL sessions, One of the room locations is going to change, so I'm gonna be updating the Excel file that just kind of gives those locations. I think it was the one that was in biology. I'm gonna move it over to Woodburn. That's where the vast majority of them are, just based off of movement and kind of preference of those CL leaders. I'm gonna move that location from biology to Woodburn. I'll point that out in the shared file on Thursday's class. But I just wanted to make you aware of that. This next up will be scale sections. Other than that, finish up module 4, probably start a little bit of review next class. And I will see you guys on Thursday.